Retrofit applications. This is an apartment complex in Tulsa. In what they did here in this particular case is they improved the thermal envelope of the building, and what that did was that the reduction of the load was more cost effective than adding more and more heat with the ground source heat pumps. And so by doing that, they were able to cut the tonnage required for this apartment complex. So it went from a occupancy level from about 10% up to 100% occupancy once people got into this building and were made aware of what the utility costs were. You can see the drilling rig in the back there. Obviously people are living in this thing while other portions of the building complex were being retrofitted. We mentioned banks here, not because a bank is so unusual, but because its load is different. Now remember, all you need to know is the annual energy flows that need to go to and from that ground heat exchanger, and banks are different than schools and different than churches in this particular slide here. So how you handle that is by doing an energy analysis, and you pick off these loads by month, and having picked off these loads by month, then you can put them in these software programs and you can get a good design. I'm not so really uptight about which program you use. I just want you to use one of them. You know, make sure that you use the science, and you can save yourself a lot of money, embarrassment, and maybe some lawsuits if you don't get it right. A number of townhouses have been done, and this is a retrofit of a townhouse that has air source equipment on it, and so the building owner in this particular case has decided that it's to his economic advantage every time one of these things needs to be replaced, the air source equipment, to replace it with the ground source. In this particular case here, the guy is the person here on the end of that lance is washing the soil back into the trench and making sure that there's good backfill, because in this particular case the heat exchanger was a Slinky, which I'll show in the next slide. And you can see by looking at this here that it is important that you do have some means of ensuring that the soil is back into the trench, and that the pipe is surrounded by soil and not by any air. Phil Albertson, who's been in this business a long time, will tell you that the amount of soil that's left on top of the trench is the amount of air that you left in the trench. So use the wise sayings of Phil Albertson in your application. So if you got a lot of soil up on top of the ground, that means that you've got a lot of air below the ground. And even if the thermal performance is all right, that soil is going to subside in those trenches, and you're going to have to come back in and do grading, and you don't want to do that. This looks like the standard project at OSU: one guy working and 4 guys watching. Hybrid systems are an important consideration, and it's something that should be looked at whenever you have an oversupply of thermal energy, which is you might get in a lot of commercial buildings throughout the country. Now, in this particular case, the hybrid system shows a cooling tower. Now, that doesn't have to be a cooling tower in every case. That could be a pond, it could be a decorative fountain, it could be any number of things. A pipe placed in concrete facades, decorative, different kind of architectural features is what I'd like to call them. Since I don't know what they are, we'll just call them an architectural feature. But a lot of this thing has been done in Europe, where they take a lot of heat out of the ground. They don't have a lot of cooling, same way I guess in northern climates in the United States, so that there needs to be some way of regeneration, and there's been some very clever ways, and I refer you back again to the publication, the International Energy Agency, and the United States is a member of that organization, a contributing member, and so that literature is available to you, and I think now it comes over the internet, and so I think if you hit www.iea.org for organization, you could probably go ahead and download their materials, which is a very important scientific publication, one that you should be reading. Here's an example of a hybrid ground heat exchanger here in my hometown of Stillwater, Oklahoma. There are 2 office buildings in the front of it. They're not large office buildings, but about 4 different businesses in each one of the 2 office buildings. And in the back are 8 residences, and with a cooling tower that's hidden off the street and out of sight. Because each one of these offices has a different landlord, and each house has a different occupant, a single circulator is placed on each heat pump, and there is no primary and secondary one. The only costs that are absorbed by the building owner, which is there just one, is the fan power and the pump power on the cooling tower. And so what you're able to do is you're able to parcel out those energy costs. We're not just only involved here in the United States. This is a Chinese trade center in Hingingden. I know that's mispronounced, but it's the best I could do. Sean Shu, University of Missouri, who is the IGSHPA coordinator in the IGSHPA chapter in China, supplied us with this picture here. Also an apartment complex in Shanghai, so people say, well, we can't use this in high density location. Well, combination of fluid rejectors and internal gains and things like that, when you take a look at the total loads throughout the year, that's when you should make your design, not when you walk around the job site. We've had some success in working with the United States Department of Defense in military bases in the United States, as well as military bases in this particular one is in Korea. There is a limited land area here, so each one of these housing units has a single borehole. We'll also have a presence in the Olympic Village in Beijing. This shows some housing for some of the athletes, and I think in some of these we'll have different kinds of heat exchangers, Slinkies in some case, and just a variety of things. But they want to demonstrate alternate energy and energy conserving technologies at the Olympics. President of the United States, George W. Bush, has a ground source heat pump system in his home in Crawford, Texas. It's a vertical system with 4 heat pumps for zone controls. He's a very proud owner of this thing. We have a lot of information about this particular house since one of our graduates, Howard Newton, of our engineering technology program here, has visited with the president on several occasions about the technology and the boreholes and the refrigeration cycle, and he seems to be very interested in this, and he has visited with his President Bush's friends about this technology, and we're talking about Alexander Putin from Russia and Tony Blair from England, and his own sidekick and Vice President Cheney, and people like that. So we were at all levels. Getting back in now to a little bit of commercial side, schools have been a good business because school boards can be talked to, because they're the custodians of the budget and they're custodians of good practices for their students and for their district. And by and large, that's very helpful. Like in military bases, the bases are going to be there. They're not going to be sold to somebody else and you don't have to worry about that first cost, because they are there. And if you're building a commercial site to be sold, you're probably going to try to be controlling your cost. And the first cost of a ground source heat pump is not necessarily the highest cost. In other words, if you go with some systems out there, sometimes the ground source heat pump comes in with the lower first cost, the lower maintenance cost, and significantly lower operating costs. So sometimes you don't have to go in there and apologize for your first cost. This is a high school in Florida, which means that we're going to have a relatively high cooling load throughout the year, and so it's important to know that we can handle those kind of loads. Interior view of the high school. Important thing right here, there are large land areas on the outside, playing fields, grassed areas where the students congregate. Excellent places for ground heat exchanger. And also put these underneath the building. You just want to make sure that if somebody did an uh-oh, that you can valve it off and take care of it.